violet pigment.
Fascinating how light can play such tricks, truly. So beyond single solid colors, sometimes the eyes tell an even more complex story through multicolored patterns, don't they?
They absolutely do. That brings us to heterochromia, which is a truly captivating condition. It's defined as having two different colored eyes in the same person, or even multiple colors within a single eye.
Two different colors, like one blue, one brown.
Exactly. That's what we call complete heterochromia, where you might have one eye that's a brilliant blue and the other a warm brown, for instance. Then there's also sectoral heterochromia, which is equally striking. That's where a single eye is split into two distinct colors, perhaps a segment of brown or green in an otherwise blue eye, like a little slice of a different color.
So it's like a natural, inbuilt, artistic swirl or pattern. How rare is this?
It's quite rare, affecting less than 1 in 500 people, roughly. While it's often a harmless genetic trait, just something you're born with, it can also develop later in life due to an injury, certain medications, or even an underlying illness, though that's less common. But yeah, it's always something that definitely makes you look twice.
I can imagine. And then there are some truly extreme, incredibly rare structural differences in the eye itself, which sound almost, well, fantastical.
Indeed. We're talking about conditions like anisocoria and what's known as cat's eye syndrome. Anisocoria is when a person has pupils of different sizes. One pupil might be significantly larger or smaller than the other. It's often subtle, but sometimes quite noticeable.
Different size pupil.
And then cat's eye syndrome, or more technically, it's often related to a condition called coloboma, is an incredibly rare genetic mutation. In this condition, part of the iris doesn't fully close during development in the womb. This can leave a distinctive keyhole or even a slit-like pupil, which genuinely resembles a feline eye. It's a significant structural alteration, and it can impact vision as well as appearance.
Wow. Okay, so what does this all mean then? We've been talking about light, melanin, collagen, but how does eye color actually work? If it's not like painting a canvas, we keep saying there isn't really blue or green pigment, so what exactly are we seeing?
That's such a crucial point, and it's a common misconception that your iris is simply colored like, a painted surface. It's not. Your iris doesn't actually contain blue or green pigments in the way paint does. The color we perceive is a complex and, frankly, beautiful result of a dance between three main things. First, how light scatters as it passes through the clear, fibrous tissue of your iris. That's called Rayleigh scattering, similar to why the sky is blue. Second, the concentration of melanin, which is always a brown pigment, even in blue eyes, just in very tiny amounts. And third, the microscopic architecture or structure of your eye tissues themselves.
So it's less about what specific colors are in there physically and more about how light interacts with the density and the arrangement of what's already there. Like the structure matters as much as the pigment.
Precisely.